All right, so we've talked about similar figures and, scale factors and ratios and even proportions to find missing sides, right? Well, what we're going to talk about now is we've talked about congruent triangles and how to figure out if two triangles are congruent. They are the same shape, same size. But with similar, they have the same shape, but the sizes are different. So that's where we have the proportions. That's where we have our ratios. So that's what we're going to be using. And with congruent triangles, we have 5 different congruency theorems. With similar triangles, there are only 3 similarity theorems that we can use to prove two triangles are similar. And 2 of them will look very familiar. First, start off with our little definitions. Similar triangles have, just as a reminder, same thing with figures. Similar triangles have corresponding angles that are congruent. And they have corresponding sides. Do we remember that word? Not congruent, but proportional. So the first theorem we're going to talk about, again, pause any time that you need the time to catch up, is going to be angle-angle similarity theorem. Now, we not call it angle-angle-angle. I'll explain why in a little bit, but this is one that cannot prove congruency because no matter how much bigger or smaller proportionally a figure gets, the angles are going to stay the same. So you cannot say they're congruent because it could be bigger. All this is saying is that if we have 2 angles of one triangle here, angles C and A, are going to be congruent to two angles of another triangle. So here we have angle A and D are congruent, and angle C and F are congruent. Therefore, we can say that triangle ABC is similar to triangle DEF. So let's take a look at 3 examples. Can we prove that these are congruent by angle-angle? All right, so first things first. We take a look at something like this first one on the left. I need you to understand this is a triangle inside of another triangle. You have a smaller triangle and a bigger triangle. So the best thing to do here, draw them separately. For instance, here we have triangle AEB. So I'm going to draw triangle AEB, and probably got the right kind of small with these examples. AEB. And we're seeing that, I'm going to draw it out here, this angle is 52 degrees. Okay? Then we want to make sure that we also see the bigger triangle, A to D to C. Okay? ADC. So that outer triangle, this is a triangle in a triangle. And we draw that guy out. We have A's up here, A, D, C. We still have that 52-degree angle. Now, the big thing we need to recognize here is when we talked about congruent triangles, we talked about shared sides or reflective sides and vertical angles. This is something else what I like to call shared angles. So here we want to make sure that we put a little asterisk here and say, look for shared angles. Shared angles will always be congruent. One fits directly in the other. They're the exact same size. So you'll also notice that when we separate the 2 triangles, they have the exact same name, A. Now there's a reason to put 2 congruent markings on that, because if you notice right here at angle B and angle C, they're already marked congruent as 52 degrees. So we do have 2 angles that are congruent. That's all we need. What ends up happening is if you use the triangle sum theorem, you add these 2 together, you're going to get the exact same sum if you add these 2 together. We know that you add the 2 angles together and subtract from 180 to get the third angle. Well, if these 2 have the same sum as these 2, that means we subtract the same number from 180. If that's confusing, don't worry about it, or ask your teacher, okay? And we can explain to you a little bit better than that. So here we can conclude that, yes, these 2 are similar, and they want us to write a similarity statement. So our similarity statement is triangle. If we start at AEB, triangle AEB, we're going to put a little similar symbol, and don't forget your triangle symbol, and the corresponding angles are ADC. Now, let's take a look at the next one. The next one here, we see vertical angles. We're always told to look out for those vertical angles, okay? But if we see here, we already have an arc, a single arc here. We have a double arc up here at angle C, and it's kind of blurry, but it's a triple arc on B. These are not congruent to any of those, so we're going to have to add a fourth arc. So we put a fourth arc on these, 1, 2, 3, 4. Well, we only have one pair of congruent angles, guys. The rest all have completely different numbers. We have no idea what the measurement of angle, what is that, L is. So, unfortunately, even though we remember, we'll put a little asterisk, look for vertical angles. I'm going to put the angle symbol, write out angles if we need to. Even though we have the vertical, no other pair of corresponding angles, no other pair of angles, period, are congruent. So the answer to this question, we would say no. Only one pair of angles are congruent. I'm going to put my congruent symbol. Okay, so we cannot say that these are similar because we only have the one pair. Now we take a look at this next one here. We're going to notice again, vertical angles. So we already have an arc, so a single arc, so we're going to put a double arc. And if you notice, hey look, angle J and angle F are congruent. And then these two vertical angles, angle JHK and FHG, are congruent also. So we do have two congruent angles. That's all we need. So yes, triangle JHK. Remembering the order matters. Put our similar symbol. Triangle J was one arc. It corresponds with F. Middle letter H is going to correspond with itself. And the last letter with no congruent marking, K, is going to correspond with G. So there's our similarity statement. All right, let's talk about the next one. Rewind if you need to, please. We're looking at side, side, side. This should sound familiar. Now, a congruent triangle, side, 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 was a way of proving congruency, but the sides were congruent. Now, we're not looking at congruent sides. Remember, your sides are going to be different. What we're looking for is corresponding side lengths are proportional. This is setting up that small, medium, and large ratio that we looked at in the previous video, or in the previous notes. So here again, in the previous notes, I told you guys you may see proportion as ratios in the fractions or with the colon. So here we see it again with the fractions. So we're saying here that, now I can't put congruent marks. They're proportional. But side AB, the length of AB, is proportional to RS. BC is proportional to ST. And CA is proportional to TR. Let's take a look at what this looks like in an example now. All right. We're just going to jump straight into it. They're similar. We're going to write a similarity statement. Let's go ahead and go with our small, medium, and our large. Here's our small side. 4 is my medium. 5 is my large. Back over here, the next one, we're looking at 9 is small. 12 is medium. 15 is large. Now, the great thing is we're not looking for scale factors, so we don't need to know which one's new and old. So we're just going to go ahead and just throw some numbers down here. Let's look at our small sides. We're looking at 3 and our other small of 9. 3 over 9. That's going to simplify to 1/3. Take a look at our medium side. Okay, the one STU went on the top, so we're putting STU on top and XWV on bottom. We must stay consistent with this on all three, small, medium, and large. Do not switch them around. Okay, so medium, STU first, 4, over XWV, 12. This is also going to simplify to 1/3. So far, so good. Always check that third side. Large, STU first, 5, over XWV, 15. And look at that. We do have another 1/3. So we can confirm, yes, these are similar. Our similarity statement right here, triangle STU is similar to triangle XWV. So compare your ratios. Let's take a look, and we'll have 3 examples at the end covering these. Last one should look familiar, side angle side. This is where your angle has to be included between the 2 sides, the angle that we're looking at. Okay, SAS, the included angle. Again, the included angle will be congruent, but the sides are proportional. So here, as it says, we've got an angle is congruent, and the lengths of the sides, including these angles, are proportional. So here we're saying angles C and F are congruent. The sides that include it, what they call it, CA and FD, are proportional, and then CB and FE are proportional. All right, let's look at this in the making here. First off, the first thing that I'm noticing here is I'm seeing that I've got 120 degrees on both these angles. So I have my A. So we have to compare the 2 sides. First of all, make sure the 2 sides are the sides that include the angle. Okay, do both these sides make that angle? Yes. All right. So now we're going to do the exact same thing we do with side, 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 but we only have to do it twice. So we have a small and a large. So here we have small, 6 will be our large side. On the other triangle, 6 is small, 9 is large. I don't know why I'm writing them. Now, we'll go ahead and we'll put triangle MNL on top and triangle corresponding parts PRQ on bottom. So let's take a look at the small sides. M and L on top, the 4 over the 6, small over small. We're going to simplify this down to 2/3. Now we look at the large, M and L, 6 on top, PRQ, 9 on bottom, and this does come down to 2/3 as well. So we have our 2 proportional sides, creating that congruent included angle. So yes, we have triangle MNL is similar to triangle PRQ. So again, pause it if you need to. Our last 3 examples are going to be a mixture. We're taking a look and we're identifying based on what we've learned. Okay? We take a look at this first one here, and we are seeing, I got vertical angles, guys. Hey, look at that. But we need to look at the count. Okay? I already have an arc here. I have 2 arcs here. I have 3 arcs. This should look pretty familiar. It's almost it is exactly like the problem we've already done. So we're going to have to put 4 arcs here. And we're going to find ourselves with only 1 pair of congruent angles. We do not have a second A. So here, these are not going to be they're not going to be similar, and they want us to write the similar statement, indicate which theorem. Well, this one, they're not similar. We're going to say only 2 pairs. Oh, sorry, only 1 pair of congruent angles. My pen's dying. I'm going to put my little symbols of congruent angles. Okay, so they are not similar. Next, we really need some room on this one. I don't have enough room to draw because we see this triangle inside of a triangle again. You're going to see these on the next notes too, but it'll look a little different. Here, this is extremely important, okay, because we're dealing with the sides. This is where you really need to separate these triangles, okay, because you need to understand this first triangle right here, LKM, okay. If we draw this guy out to the side, here's L, here's K, I'm sorry, K, L, M. We're going to see that KL is 6 and LM is 10. Now, when we draw the bigger triangle out, I need you to see what's happening, ladies and gentlemen. This is going to be triangle JLN. Side JL is not 3. Side JL is the entire length. You have to add 6 plus 3 to get you the full length of 9. Same thing over, leave myself enough room here. We need to do 10 plus 5. Okay, and that's going to give us the entire length of LN as 15. Now, we do have this shared angle. Okay, so angle L is going to be a congruent angle. Here we're right, shared angle. So we just need to look at our small and large sides and see if, sorry, it's kind of messy, see if they do come down to the same ratio. So this is our small side and our large side. Down here on the other one, small side, large side. So let's take a look at the small. We'll put the 6 over the small down here of 9. We're going to simplify this down to 2/3. Then our large side, we have to back up to the smaller triangle, 10 over the large side over here, 15, and this will come down to 2/3 as well. So we do have it. Again, this is one of the trickiest ones because it's not telling you the full side. Like, you have to do the addition. Okay, it's not that hard. Add the two numbers together to get the bigger triangle. So here we can say yes. We'll say triangle KLM is similar to triangle JLN. And we also want to know how by side angle side similarity. And if you leave off the similar symbol, it's not that big of a deal. I know my number 7 got here in the answer, or page number 7 got in the answer here. Just cover that up, okay? But our two triangles are similar by side angle side. All right, next one's fun. One thing I want you guys to remember here is we do have a set of vertical angles, okay? So we do want to see these vertical angles. But we also see these three sides. There are two different ways you can approach this. You can approach this as, are they similar by side angle side, if we forget about these other sides, or by side, side, side. It does not matter which one. Generally. Now, because they gave us all three, we're going to go ahead and check out all three sides. We know the angles. But remember, we had a problem earlier, it might have been in the previous notes, that that the sides, the angles all were congruent, but the sides were not, which, you know, mathematically is impossible, but, you know, we're going based on, we need to make sure that we check these numbers, okay? So let's check out our sides. Here's our small. That is not the small, Miss Collins. That is the middle. 5 is smaller, right? Medium and large. Everybody agree? Over here in the triangle down here, RTS, we've got small as a decimal. It's all right. Medium and large. Let's check out our sides. Small. We'll put the top triangle on top, bottom triangle on bottom, just to make it easy. 5 over the small side over here, 12.5. When we plug this in the calculator, most calculators are going to give you a decimal. It's going to say 0.4, okay, or 2/5. Either way. Doesn't matter which one. Just make sure they're all in the same format. So our medium here, 6 over 15. And this will simplify down to your 2/5, okay? But we want to see that 2/5 as the 0.4 so that we have the same format. If the first one's in decimal, second one's in decimal. And then our large, top triangle 8 over the bottom triangle, large side of 20. We're going to find out this is 0.4 also. So check, check, check. We're going to say yes, these triangles are similar. So triangle, I'll start at R, R, Q, P. And as a reminder of making sure corresponding parts are together, triangle R corresponds with R. I went down the smaller side to the next angle, Q. So here I need to go down the smaller side to T. And then finish it off with that last one. By, and in all reality, side, 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 we'll just leave it as side, side, side. Because we know side, 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 we can also say side angle side, but we're going to leave it as making sure you always check those sides. Again, as always, ask your teacher if you have any questions, or you can Google search some other videos on similar triangles if you need some additional help.